There are about 79 universally recognized mathematical constants, and I'm going to explain every one of them. Level 1. Basically everyone's heard of these at least once in their lives. Pi is the ratio of a circle's circumference to its diameter in Euclidean geometry. It's also the most well-known mathematical constant, and it appears basically everywhere. E is the base of natural logarithms, defined as the limit from n to infinity of 1 plus 1 over n to the power n, or the sum of k greater than or equal to 0 of 1 over k factorial. This number is central to calculus because the derivative of e to the x is e to the x. Phi is 1 plus the square root of 5 over 2, and it's the most aesthetic number. Root 2 is the length of the diagonal of the unit square, and legends say that one day in Greece, a man called Hippopotamus was chilling with the goon squad and decided to test Pythagoras' theorem. He drew a right-angled triangle with side lengths of 1, but when he tried to find the exact length of the hypotenuse, he proved by a simple, rigorous argument that this value could not be a rational number. Maths is broken. For Pythagoras and his followers, the universe breathed through rational numbers. Irrational numbers hadn't been discovered yet, so this was like somebody just came along and broke mathematics. The choice was simple: embrace the new truth and redesign the entire framework, or silence it and keep the current framework tidy. The legend goes that Pythagoras chose silence. The newcomer who spoke the truth was expelled, and in some stories he was thrown overboard on a ship. Tablets were sealed, teachings were watered down, and the forbidden name whispered only behind cupped hands. Hippopotamus. I is the complex number satisfying I squared equals minus 1. Fun fact, e to the I pi equals minus 1. Somehow. 0 is the additive identity. A plus 0 equals A for all numbers A. 1 is the multiplicative identity. A.1 equals A for all numbers A. ln2. When you raise e to the power of a number and get 2, that number must have been the natural log of 2. It's useful in computer science where bits are often in base 2, but the universe is in base e. ln10 is useful for converting between natural logs and common base 10 logs. Minus 1 is the multiplicative inverse of 1. Root 3 is the height of an equilateral triangle with side lengths 2. Root 5 is also irrational, and it's found in the golden ratio. Level 2. Number file fanboy. Log base 2 of e is the conversion factor from the natural base to base 2. Tau is just 2 pi, and some people think that we should use tau instead of pi. I happen to agree with them because Terence tau. Pi squared shows up randomly in integrals and series. E to the pi, or Gelfond's constant, is a famous transcendental value. 2 to the root 2 is the Gelfond-Schneider example linked to the Gelfond-Schneider theorem, which states that if A is algebraic and B is irrational and algebraic, then A to the power B is transcendental. The 12th root of 2 is the semitone frequency ratio in a 12-tone equal temperament. Basically, it's used in music. Level 3. Math undergrad. The Euler-Mascheroni constant is the limit from n to infinity of the sum from k as 1 to n of 1 over k minus ln n, and it helps in solving integrals involving logarithms and exponential functions. Pi squared over 6, also known as the Basel value, is equal to the sum of 1 over n squared, where n is a natural number, or zeta 2. Zeta 3, also known as Apéry's constant, is equal to the sum from n is 1 to infinity of 1 over n cubed. Oh! Catalan's constant is a slowly converging series defined by the sum from n is 0 to infinity of minus 1 to the n over 2n plus 1 squared. Brune's constant is the sum of the reciprocals of all the twin primes. Feigenbaum delta describes how quickly the spacing between bifurcations shrinks in a system approaching chaos. Feigenbaum alpha describes the scaling of the width of the attractor in the bifurcation diagram. Champernowne's constant is constructed by concatenating all the natural numbers, and it's an example of a normal number, which is a number where every digit 0 through 9 appears equally often in the long run, and every possible sequence of digits eventually shows up. Louis-Field's constant is defined as L equals the sum from k as 1 to infinity of 1 over 10 to the k factorial, and it's an example of a constructed transcendental number, meaning it's not the root of any non-zero polynomial equation with rational coefficients. The omega constant is the real solution of omega e to the power of omega equals 1. The Dotti number is a unique real solution of cosine x equals x. Level 4. Losing the will to live. Euler's number to the power of the Euler-Mascheroni constant. This is the oiliest constant known to man, and it's also the normalizing factor in many asymptotics. The Miesel-Mertens constant is defined as the limiting difference between the harmonic sum over the primes and the natural logarithm of the natural logarithm, p. The twin prime constant is defined by this infinite product of all odd primes, and it helps estimate how frequently twin primes occur among the integers. The Ramanujan-Soldner constant. If we define the logarithmic integral function like this, then the Ramanujan-Soldner constant is defined as mu such that Li of mu equals 0. Landau-Ramanujan constant. The number of positive integers less than x that can be written as n equals a squared plus b squared grows approximately according to the ratio k dot x over square root ln x. Smith's constant is the real root x cubed equals x plus 1, and it's the smallest real algebraic integer greater than 1, with all its conjugate roots having absolute values less than 1. Ramanujan's almost integer constant is made up of two transcendental numbers and an irrational number, but it's very close to an integer. The lemniscate constant is a transcendental number that works similar to pi, but instead of helping to find the arc length of a circle, it helps to find the arc length of the lemniscate of Bernoulli. Gauss's Guilliat number is defined as the reciprocal of the arithmetic mean of 1 and root 2, and it's also the complete elliptical integral of the first kind, and we can define it with the gamma function, and it's related to the lemniscate constant. The golden angle derived from the golden ratio represents the angle that divides a circle in such a way that the ratio of the larger arc to the smaller arc is the golden ratio. Level 5. Oh, I actually wrote my dissertation on this. The Glaisher-Kinkelin constant shows up in the study of the k function and the Barnes-G function, which generalizes the superfactorial function like so. Basically, it's a hidden scaling factor that helps us relate the superfactorial to the k function. Khinchin's constant. For almost all real numbers x, you can write x as a continued fraction like so. Then the geometric mean of the continued fraction coefficient, a1, a2, a3, and so on, approaches a constant as n approaches infinity. That constant is the Khinchin's constant. The Khinchin-Levy constant. Using the same continued fraction as before, let p sub n over q sub n be the continued fraction x with m layers. Then the limit as n approaches infinity of q sub n to the 1 over n equals e to the beta, or the Khinchin-Levy constant. Lemma's number is the largest real root of the Lemma polynomial, and it's also the smallest known Mallah measure. A Mallah measure is just a way to measure the size or complexity of a polynomial. The Erdős-Born constant is defined as the sum of the reciprocals of the Mersenne numbers, the Fibonacci constant. Similar to the golden ratio, this is the limit of the ratio of successive Fibonacci numbers. The Gieseking constant is the volume of the Gieseking manifold, which is a non-orientable hyperbolic 3 manifold of finite volume. Bernstein's constant is defined as the limit of the scaled error in the best uniform polynomial approximation of the function f of x equals mod x on the interval -1 to 1. So mathematically we write beta equals the limit from n to infinity of 2n e sub 2n of mod x, where e sub n of f is the error of the best uniform polynomial approximation of the function f. Sierpinski's constant. Let r sub 2 of k be the number of representations of an integer k as a sum of two squares. Then Sierpinski's constant is defined by the limit as n tends to infinity of the sum of k is 1 to n of r sub 2 of k over k minus pi ln n. Salem constant. Sigma, sigma boy, sigma boy, sigma boy. A special type of algebraic integer greater than 1 whose conjugates lie on or inside the unit circle with at least 1 on the circle. The Feller-Tournier constant represents the density of positive integers with an even number of prime factors, each raised to a power greater than 1, excluding prime factors raised only to the first power. It can also be expressed using an infinite product over primes p sub n. Mills' constant a is a constant where the floor function of a to the 3 to the n is prime for all positive integers n. The Euler-Gompertz constant is defined using this integral and has connections to divergent series and special functions. The reciprocal Fibonacci constant is defined as the sum of the reciprocals of the Fibonacci numbers. Level 6. De Broglie-Neumann constant. Let h sub t of z be a family of entire functions defined for real t and complex z, structured from the Fourier transform of a certain rapidly decaying function. The de Broglie-Neumann constant lambda is the unique real number such that h sub t of z has only real zeros if and only if t is greater than or equal to lambda. In 2018, Sigma Male Brad Rogers and GigaChad Terence Tao proved that lambda is greater than or equal to 0. Meanwhile, I still use my phone to look for my phone when I think I've lost it, even though it's literally in my hands. Bloch's constant. For each f in curly f, define b of f as the supremum of all radii r such that there exists a subregion S subset of D where f is injective and f of S contains a disk of radius r where D is the open unit disk in the complex plane. Then Bloch's constant is the infimum b of f over all functions f in the family of curly f. Landau's constant. Let curly f be the set of holomorphic functions f defined on an open region containing the closure of the unit disk D, satisfying f of 0 equals 0 and f prime of 0 equals 1. Now for each f in curly f, define curly L of f as the supremum of all radii r such that the image of f of D contains a disk of radii r. Then Landau's constant L is the infimum of of curly L of f over all functions f in the family curly f. The transfinite diameter measures the size of a set in terms of its potential theoretic properties. Let mu be the probability measure supported on E, where the Robin constant V of E is defined as the infimum over all probability measures mu supported on the set E of the double integral E times E of the logarithm of the reciprocal of the distance between Z and W integrated with respect to mu of Z and mu of W. Then the transfinite diameter gamma of E is e to the power of minus V of E. Porter's constant is the average number of steps the Euclidean algorithm takes, and it's also equal to this, where gamma is the Euler-Mascheroni constant. Locke's constant. Let m be the number of terms in the continued fraction expansion of a real number x in the interval from 0 to 1 required to determine the first n digits of x. Then for almost all x, Locke's constant equals the limit from n to infinity of m over n, which is 6 ln 2 ln 10 over pi squared. Artin's constant. For an integer a, the set of primes which a is a primitive root modulo p has a natural density. And under certain conditions, that density is given by c sub Artin, which is the product of p, which is prime, of 1 minus 1 over p minus 1. Level 7. Literally Ramanujan. Conway's constant. The look and say sequence starts with 1 and each subsequent term is generated by describing the previous term's digits. So for example, we have 1, now we have 1 1, so we write 1 1. Then we have 2 1, so now we write 2 1. Then we have 1 2 and 1 1, so we write 1 2 1 1 and so on. Conway's constant describes the asymptotic rate of growth of the number of digits in the terms of this sequence. The Commonic-Loretti constant is the smallest base greater than 1 for which the number 1 has a unique representation in its Q expansion. It also satisfies the equation that 1 is the sum from k is 1 to infinity of t sub k over q to the power k, where t sub k is the kth term of the Thue-Morse sequence. Kepner's constant. The sum of reciprocals of integers diverges to infinity, but Kepner showed that if you exclude all the terms where the denominator contains a specific digit, e.g. 9, then it converges. The Copeland-Erdős constant is a real number formed by concatenating the decimal representations of all the prime numbers in order. The Vis-Wanath constant. The random Fibonacci sequence is a variation of the classic Fibonacci sequence where each term is formed by randomly choosing the sign plus or minus. Vis-Wanath proved that the absolute value of the terms in this sequence grows exponentially with probability 1, and the growth rate converges to the Vis-Wanath constant. Hafner-Sarnak-Mercalli constant. Let d of n be the probability that the determinants of two randomly chosen n by n integer matrices are relatively prime. Then the Hafner-Sarnak-Mercalli constant is the limit from n to infinity of d of n. The limit is given by this infinite product. Backhouse's constant. Let p of x equal 1 plus the sum from k is 1 to infinity of p sub k x to the k, which is 1 plus 2x plus 3x squared plus ... where p sub k is the kth prime number. Then its multiplicative inverse is this power series, so the Backhouse constant is defined as the limit from k to infinity of q sub k plus 1 over q sub k. Trefethen constant. Consider the recurrence relation x sub n plus 1 equals x sub n plus or minus beta x sub n minus 1, where beta is a fixed positive real number and plus or minus is chosen at random and with equal probability. For each beta, the sequence x sub n almost surely grows or decays exponentially, and the asymptotic rate of growth is given by sigma sub beta, which is the limit from n to infinity of mod x sub n to the power 1 over n. The Trefethen constant is the critical value b star such that 0 is less than beta star implies sigma beta is less than 1. And the sequence decays exponentially, and beta being greater than beta star implies sigma beta is greater than 1, and the sequence grows exponentially. Heath-Brown-Moroz's constant. For each prime number p, take 1 minus 1 over p, raise it to the 7th power, then multiply it by 1 plus 7p plus 1 over p squared. The Heath-Brown-Moroz's constant is the product of all these results put together. Finally, someone made a constant that is actually useful that we think about every single day. The MRB constant is the upper limit of this expression, and it's still unknown whether it's rational, irrational, algebraic, or transcendental. The prime indicator constant encodes the pattern of prime numbers into a binary number. Basically, you go through all the natural numbers, and for each prime number, you add 1 over 2 to the n, and for non-primes, you add nothing. The Fourier constant. Start with any positive number x sub 1 is greater than 0, then define a recurrence relation like so. Then the Fourier constant alpha is the real number such that if x sub 1 equals alpha, the sequence x sub n diverges to infinity, and for all other values x sub 1, the sequence has two accumulation points, 1 and infinity. The unqualified constant is the number of people who comment below this video, "Oh, but you forgot the big gay sweaty bum crack constants." Listen, no one cares. You can take your little comment and shove it up your arse. Click this video if you want to see more, join the channel, and piss off.